Hi, my name is Davis, and I want to talk to you about my favorite maker tool, the 3D printer. I've had this 3D printer for about a year now, and I find it to be a great resource for making all manner of things. Useful things like the latches and hinges on this cabinet, to silly little toys like this little octopus. To walk you through the process of printing something, we'll go out to Thingiverse. It's a popular website with 3D models, and we'll search for just a little rocket maybe to print. There's this little retro rocket they have out there that's kind of cute. And there it is. Now Thingiverse has thousands of models, and they're all free to download. I'll go grab the file for this particular model. There it is. I'll download it. Now I'm going to load it into a slicer. This is Ultimate Kukura. It's a popular slicing program. I'm just going to go grab the file. So the slicer is a utility that converts a 3D model into instructions for a 3D printer. It really tells the printer exactly how to lay the plastic down in order to build up this model one layer at a time, starting from the very bottom. So here I'm going to scale this thing down a little bit. I think that's a little large to start out with, so we'll scale this one down. And then I'm going to tell it to go ahead and cut it, or slice it. This is a somewhat complicated model, so it takes it a few minutes to run through all the calculations necessary to make the print. And there it is, and now it's ready to print. So we'll send it to the printer. Here's a little stop motion video captured while the model was being printed. This is sped up quite a bit. It actually took about an hour and a half, almost 2 hours to print. One of the best modifications I've made to my 3D printer was to attach a Raspberry Pi and install Octoprint. Octoprint is a piece of open source software that allows you to remotely control your 3D printer over your network. It has a friendly web interface where you can go to check the status of your prints and even start a new print job. Plus, it is attachable to most of the common slicing softwares out there that are used to prepare your 3D print jobs, so you can send print jobs directly to the Octoprint. Before Octoprint, I had to put the print job on an SD card, install it in this small slot, and then initiate the print job from here. And then the only way to monitor the print job was to come and look at the printer. But Octoprint has a webcam attached to the Raspberry Pi, which allows me to remotely view the status of my print, as well as check the status through the web interface. Occasionally I like to design my own thing to print. Here you see a sketch of a simple vase that I pictured making, and then I'll take you into some design software where I actually design a vase following this model. Here I'm using Fusion 360 to actually generate the model of the vase that I just sketched out. So I'll start by creating the base of the vase. This is going to be a circular reference that I will extrude up and shape into the vase. Now I want to have this vase to have a nice little groove along its outside, that little spiral groove you could kind of see in my sketch. So what I'm doing here is creating an arc. I'm going to measure. I want this arc to be a 40-degree arc, so I'm going to multiply it 9 times around in a circle. We'll see that in a minute. Now I'll create a little a reference line, and now I'm going to create an arc. I'm going to use another arc. This one will arc the other direction to create the groove up the side of the vase. Now, I need to multiply this simple arc 9 times to fill out the full circle of the arc. So I'm going to use the circular pattern tool. select the center point of the circle and simply tell it to replicate 9 times. And there it is. I'll mark the sketch finished. Now we'll extrude this out into a cylinder. Notice the grooves up the side of the model. I'm going to extrude this a little extra tall, and you'll see why when I get to it toward the end. I'll put some faces around the edge just to give it some definition. We'll extrude it downward about 10 millimeters again, just to give myself a little space, and you'll see why. That's it, we'll create a new body. Now, I can grab the various rings around the outside of this cylinder and resize them to form the shape of the base. You start with these lower rings. Notice I can also twist these rings, put a twist in that groove at the side. I'll start with resizing them now. That's about right. I'll resize the next one. It's got a good kind of body on the base. I'll leave that next joint alone, and this one I'm going to squeeze in a little bit to give that little neck to the base. And I might size this out, the top one up, just to open the mouth of the base a little bit. And there it is. There's the body of the base. I'm going to raise and lower these rings just to fatten out the body of the base a little bit. I'm going to fill the holes at the top and the bottom of the base. At this point, just make it a solid form. I use a special mode on the slicing software to convert the solid form into a base form. You'll see more about that later. Now I've capped off the base. Notice the bottoms are rounded off a little bit. I'll slice those later to get a nice flat edge. Now to put a little twist in the base, just so those grooves have a nice little twist. Just rotating each one of these rings a little bit. That would be an over rotation. There we go, that looks pretty good. I like the way this is looking so far. It's a little counter rotation on this top. Nice little twist. And I think I want to rotate that the other direction a little bit. So let's go do that. Alright, I think that looks pretty good. Maybe just a little more twist. Now that looks good. Okay, so we'll finish the form. Now to clip the top and the bottom to get a nice flat edge. So to do that clipping, I'm just going to create little blocks that I slice through the model with. So we start with a sketch plane, and then I just create a couple of rectangles. First one is going to slice off the bottom of the vase, and the other one will slice the top. That's it. That's my sketch. So now let's extrude those slicing rectangles out. I'm going to extrude these in both directions symmetrically. And notice it's automatically going to convert this to a cut mode as I slice through an existing object. The red block tells me it's cutting. That's exactly what I want it to do. That looks about right. So I'm going to click OK. And there it is. That's ready to print. Now notice it's a solid form. We'll take care of converting that to a vase in the slicing software. So I'm going to export this to an STL. That's the common 3D model software that the slicing softwares like to use. I'll just name this, call this vase 2. And that's it. Now we're ready to load it into the slicer. Just like I did before. This is Ultimaker Cura. That is one. It's a commonly used slicer. There are many of them out there, but it's one I like to use. Just go open that STL file that I just created. That's vase 2. And there it is. Now that's pretty big. That's bigger than I want it to be. So again, I'm going to scale this down, much like I did the retro rocket. Yeah, notice it's almost 150 millimeters tall. Just for this test print, I want to scale it down a little smaller, so I'll just resize it. Let's make it 775. There it is. It's a better size for the print. Now, this is checking the plastic material I'm using to print and the nozzle size. I'm checking some of the settings. Now in this case I want to use a special mode called spiralized outer contour. This will hollow out the model and print the outer wall in one continuous line up the side. This is why I didn't have to bother with hollowing out the model in Fusion 360, because the slicing software does it for me. And there it is. You see a hollowed out model ready to print. And we're ready to send it to the printer. Much like before. Now this is Octoprint. I talked about this a few minutes ago. This there you can see the vase has been loaded into Octoprint. You can also see here the temperatures. So the printer has to heat up the nozzle that the plastic will be extruded through, and it also heats up the print bed that the model is being laid down on. This will take a few minutes, so I'll kind of speed this up a little bit. Okay, now that the printer has reached the desired temperatures, it's ready to start printing. You can see the print head is moving down. It's moving to the home position. The print head will move down to the level of the base, and it's right up there in the front corner. And you'll see it start. We'll lay down a little plastic on the side just to kind of get the plastic moving. Again, this is just a little waste strip of plastic on the side. Now we'll move to the center of the print bed. It's going to put an outer ring of plastic, again, just to kind of get the plastic moving and kind of let you verify that things are coming out all right. So. We'll see it put on a couple of revolutions. Now it's ready to start actually laying down the base of the base. So this is as simple as just a long string of plastic filament being forced through a hot metal nozzle that's very much like a hot glue gun, but it's being forced through at very predicted rates and laid down on a bed. This is another view, so you can actually kind of see the instructions that are being sent to the printer as they're being sent. Here's the information about the model that's being printed, but here you can actually see the what's actually being drawn on the print bed as it's being printed. This is, when I'm watching it remotely, this is one of the views I like to use just to kind of check the status of the print to see what it's currently printing. It's a little easier than trying to see it through the webcam. I'll do the sped up stop motion view. A little choppy, but you can see the vase forming up nicely. And there it is. There's the vase. It's finished printing, and you can see it's full form. This will hold water. It's just a simple little vase. A more practical example of something I've modeled and printed is this remote control battery cover. Thanks for taking the time to watch my video. If you have any questions or would like to talk to me about 3D printing, feel free to contact me at my email address.